Hello student, this is your seventh lecture of Power System 2. Today we are discussing about the per unit system. What is per unit system? Power system equipments ratings are expressed in megawatt, MVA, kV, kiloampere, ohm and hertz. Okay, express all these quantities in a per unit system, or we can say a percentage of a reference base values. Okay, so per unit method is a simple and more informative than the actual values. Okay, for example, if you want to convert the some selected voltages into per unit, and we take the base voltage is a 110 kV. Okay, if we want to convert the 66 kV into the per unit system, and if we take the base as a 110 kV, then what will we get in per unit? In per unit will we get the 0.66, okay, per unit. uh, Now if we want to convert the 110 kV into per unit, and similarly we take the 110 kV as a base value, then we get the 1 per unit. Okay, so simply we divide the real or actual values by the base values, and this is the also if you want to convert in a percentage, then simply multiply 100 by per unit values. Okay, so how this the per unit system PU system value is defined? Per unit value is equal to actual value of quantity in any unit. Okay, in any unit, unit doesn't matter. Okay, base value of quantity in a same unit. Okay, so this is the very important thing, that your both the part of division, upper and lower part, should be the same unit. Okay, so actual value of quantity is in a volt or kilovolt, then its base value is similar unit, have similar unit like kV, then below also we have to put the kV value, then we get the actual per unit value. Okay, power base is a considered in a MPa. Okay, there are two type of base value. One is a power base, and in power base we take the MVA value as a base, and in a voltage we consider kV, kilovolt, in a as a base value. Okay, so for voltage, current, impedance, if any two of are selected as the base value, third is automatically in a base value. Okay, so we have only two type of base value, power and voltage, other are derived from that. Okay, so let one example, or we can say one explanation how we can find the per unit value. Okay, so if we take the base value, base volt ampere as a MVA base, and base the voltage is equal to kV base. Okay, so these are our two bases. Okay, now we want the base value for a current and impedance. Okay, so as I said earlier, we have only two base value. Okay, power and voltage, other are derived from that two power and voltages. Okay, so if you want base current, then how we can calculate base current IV? Okay, what is the normal equation of current? I is equal to, if we take the power equation, P is equal to, let me write, if we take this value, P is equal to VI. Okay, V into I. Then and now if we want to calculate this I, then what will we do? We do the division of power divided by voltage. Okay, so power is in MVA, we have a MVA base, and in division we have a kV base. Okay, and it should be in 10 raised to, why this 10 raised to 6 is multiplied, because we take the MVA mega. Okay, and this is the kV, so we multiply the 10 raised to 3. Okay, so after doing this, if 10 is to 3 is cancel out from upper and lower part, then we get this value. Okay, and we get the per unit current. How we can calculate the per unit current? Per unit current is nothing but the actual divided by base, and base already we found the base value. Okay, here. So this will give our per unit value of current. Okay, so this is the derived. Okay, derived from the voltage and power equations. Okay, then if we want to calculate the base impedance, because if we want to find the per unit impedance, then we need this base. Okay, actually we have actual value of impedance we already have. Okay, but we want the value of base impedance. Okay, so in that case we have to calculate the base impedance, because we don't have a ready-made base value of impedance. Okay, so how we can derive normally equation of impedance, or we can say impedance or resistance is equal to V upon I. Okay, so we can say voltage divided by current. Okay, so this is the Z. Then we put the base value of voltage and base value of current. Now why we put this base value of current? We don't have any ready-made base, but we found it in a previous step. Okay, this is our base current now. Okay, so put this all the values, and this is the current IV, and this is the kVA base into 10 to 3. But we don't have a ready-made formula of IV. Then we put this formula into this equation, and we get this one. Okay, and after, at the end, finally we get this value. Okay, so whenever you want to calculate base value, ZB base impedance, okay, then what will we do? KV base. Okay, so base KV whole square and divide by MVA base. Okay, because we have only two values, voltage and power. So ultimately we have to convert all the formula in terms of voltage and power. Okay, so this is our calculation, how we can calculate this. And then we can easily find the per unit by dividing the actual and divided by base. Okay, so per unit impedance is a directly proportional to the base MVA and inversely proportional to the square of the base value, which is already shown in the equation. In power system, per unit impedance of equipments are defined corresponding to their own power base MVA and voltage. So this is the per unit impedance. Okay. It is required to bring per unit values of impedance of each equipment to a new common power base MVA and KV. Okay, so now another problem is that when we change the MVA value and KV value, then its per unit value of impedance will be changed. Okay, so whenever we change any of two quantities, either MVA base or KV base, then we have to convert the per unit impedance to a new base values. Okay, so how we can convert? This is the MVA base old, this is KV base old, this is our new MVA base, and this is our new KVA base. Then we have also have a Z per unit old, and we want to calculate this Z per unit new. Okay, so according to equation, we have this equation to calculate the Z per unit new. Okay, so remember this formula. Keep in mind that Z per unit new is equal to Z per unit old into MVA base new by old, and KV base old by new. Okay, so don't confuse with the new is a upper or lower. Okay, so simply if you try to mug up this formula, then try, keep in mind this condition. If you want, if you put this new here, then definitely power new is on the upper side. Okay, and opposite is for voltage. Okay, so here you have a old value. Okay, old value KV square. Per unit analysis reduces the chance of making mistake in a phase value and line values. After you will see that in per unit system, we don't need to convert the phase value into line values. As in a real system or in a actual values, we have to convert the voltages and currents from phase value to lines value if we want to calculate for the star or delta connection. Okay, but in case of per unit system, we don't need to change, or we don't need to convert the phase value into line values. Okay, so this is some good factor about the per unit system. Okay. Then we have a actual impedance of a transformer for a low voltage winding system. LV and HV is a different. Okay, in actual system. Okay, actual value of LV winding impedance is a low. Okay, and HV winding impedance is a high. Okay, so this is the truth about this is the fact about the impedance of the transformer. Okay, per unit value of impedance of transformer is the same whether it is referred to LV winding or HV winding. So this is the another advantage of per unit system, that you don't need to calculate or don't need to uh, convert when you refer the system from LV to HV or HV to LV. Okay, so this is the this is also a very important advantage. So this is some these are some calculations. Okay, ZP is a transformer impedance referred to primary, ZS is a referred to secondary. These two are the voltages and these two are the currents of primary and secondary respectively. Okay, if you have this formula, ZP is equal to Z as VP upon VS. Okay, and if you use this formula for a per unit system, then what is the original formula of per unit impedance? Power divided by voltage. Okay, in place of power we put the Z into I. Okay, so it is also a power. Okay, Z V is equal to IR. Okay, so V is equal to IR. So if we put this formula, then it will doesn't alter anything. Okay, so ZP into IP divided by VP. Now, if we put the value of ZP, here we have a Z value of ZP in terms of ZS. So you got these values. Okay. Now, some after some modification, like square values are compensated here from in upper part we have a VP square, and in lower part we have a VP. Then one VP is get cancel out, and we get this equation. Then if we convert these values from ZS to this VP and IP, what represent this combination, this multiplication represent the primary power. Okay, primary side power. P is equal to VI. Okay, so VP into IP, it will be the same like Vs and Is, because power never converted. Okay, in transformer, both side, primary and secondary side, power will be same. Okay, and frequency will be same. Okay, so we can write as VPIP is equal to the VSIS. Okay, so we convert we write like this, and after this we again cancel out one VS. Okay, so finally we get ZS into IS upon VS, and ultimately this is the ZS per unit. Okay, so we got the result. ZP per unit is equal to ZS per unit. Okay, so this is our ultimate formula for how this impedance is equal when we refer primary to secondary, or we can say LV to HV or HV to LV. So base MVA is selected. How we can select the base value? Base MVA is selected equal to the sum of the ratings of various equipments on a system, or equal to the capacity of largest unit. Okay, so while choosing the MVA value, keep in mind that you choose the sum of the ratings of various equipment, or you can choose the largest unit value MVA base. Okay, as a MVA base. And while choosing the base kV is selected from the any section of the power system. Other part of the system is separated from a original part by transformer. So when we go through the transformer, then its primary side we have another base voltage, and in secondary side we get the another base voltage. Okay, but power will be same at the both side. Selected base kV is a transfer to new base kV through turn ratio while propagating towards the other power system equipment. Okay, so it will be clear when you study the how we can convert the base value and all. Okay. If base kV on primary side is known, then base kV on secondary side is okay. If you have a base value on primary side, then how you can convert the base value for secondary? Then simply by using the turn ratio. Okay, you can use the turn ratio, or if you have a voltage ratio, then also it is a similar like a turn ratio. Okay. So in next lecture we will see the one example how we can convert the base values. Okay, so this is the example which will we will discuss this example in next lecture. Okay, so up to now if you have any doubt, then comment down in the comment box, and also mention your name and enrollment in the comment box so that it will be counted as your online attendance. Thank you.